Hey everyone, so this mini lecture covers the adding and subtracting of what we call unlike fractions. So what's an unlike fraction? So let's say you have a fraction that says 3/5 plus 1/3. We call these unlike fractions because of the denominators, right? The denominators are different. If the denominators were the same, such as 1/2 plus maybe another 1/2, right? The denominators are the same as 2's. So you would just treat that as such. You would write them with the answer having the same denominator, then just add the two numerators, right? 1 plus 1, so then you get 2/2, which we know to be 1. However, when the denominators are different, unlike fractions, then we have to do it a different way. So what you should have already covered is the LCD, or maybe you've heard of LCM, which is least common multiple. Well, LCD is least common denominator. So we're going to need that when adding or subtracting unlike fractions. So I'm going to do each of these two different ways. So either way is fine, whatever you're comfortable with, and you may know another way, which is also fine. So we have 4/5 plus 4/7. You need to understand how to find the LCD. Maybe you've learned it through prime factorization or some other way. So the LCD here is 35. So I will make two new fractions with a 35, the LCD in the denominator. I say to myself, okay, how many times does that 5 go into 35? Right? And I would say it goes 7 times. So therefore I multiply that 4 times 7. And I get my new numerator of 28. Do the same thing to the other side. How many times does 7 go into 35? Right? I would say 5 times. So therefore I multiply that old numerator of 4 times that 5 that we just came up with. 4 times 5 is 20, which makes my new numerator. And now you see you have 28 over 35 plus 20 over 35. And what did we just say a few moments ago above and to the right? When the denominators are the same, you just go ahead and add the two numerators and keep the same denominator. So this will be 48 over 35. So let's look at this other method that we want to look at. So we have 4 over 5 plus 4 over 7. Another student of mine showed me this method, so we'll call this the K method or the KB method. And here, what we do first, let's use a different color, we take and multiply the denominators. So this isn't the LCD, but this isn't always the LCD, but sometimes it can be. But either way, this is the method. You multiply the denominators and you get that product of 5 times 7, which is 35. Right, so we get a 35. The next thing we want to do, now I'm going to erase that, what we have there, and show you what we're going to do next. The next thing we're going to do is go ahead and multiply across. 5 times 4, which is 20, and 7 times 4, which is 28. And they do have the same denominator again, so we'll say 20 plus 28 is 48 over 35. And then you see you have the same answer, 48 over 35. Okay, let's try a different one. That one probably didn't look too different because the LCD was 35. And then when we multiplied 5 times 7, you still got the LCD of 35. So you're probably saying, okay, that didn't look too different. There were still two different ways, and we're gonna show the difference even more now in this next problem. So 7 over 6 plus 1/3. I'll write this over again, 7 over 6 plus 1/3 for the second way. So the LCD here is 6, right? 6 is the smallest number that 6 can go into and 3 can go into. That's the smallest number. So how many times does 6 go into 6? Goes once, so I multiply 1 times 7 to get 7. How many times does 3 go into 6? It goes twice, so I multiply 1 times 2 to get 2. So now I add 7 and 2 to make 9 over 6, right? Because they have the same denominator. And now 9 over 6 reduces to what? We say 3 goes into 9 3 times, and 3 can go into 6 2 times, 3 halves. If you want to change that to a mixed fraction, that's fine. Divide 2 into 3. You get 1 with a remainder of 1, so this would be 1 and 1/2 if you wanted to change it to a mixed number. All right, so now let's take a look at the other way, the KB method, where we're going to multiply 6 times 3, so we get 18, right? Unlike the last one, where when multiplying them, we got the LCD. Well, this time we don't when multiplying them, but that's okay. So now, what do we want to do? We want to go ahead and take 6 times 1 and 7 times 3. So 6 times 1 is 6, 7 times 3 is 21. So it's an addition problem. They have 18 as the denominator, so you're going to write them both over 18 and just add the 21 and 6. So that gives you what? 27. And now you still have to reduce all fractions, so you say to yourself, you say maybe 9 can go into 27 and 18, right? 9 can go into 27 3 times, 9 goes into 18 twice, right? So now in that example, you should have kind of fully seen the difference in the two methods, where one you start out with the LCD and the other one you just start out with multiplying the denominators, which sometimes, as shown in the first problem, could be the LCD, but in this case it wasn't. All right, let's try another problem so we can make sure we have the hang of this. So the next problem is 1/2 plus 11 over 8. 1/2 plus 11 over 8. All right, so the LCD of 2 and 8, what is that? It's 8, right? Because 8 is the smallest number we have that 2 and 8 can go into, right? There are other numbers like 16, 24, 32 that 2 and 8 can all go into. However, 8 is the smallest one, the least one that they can go into. Therefore, it's the LCD. So we say, okay, 2 goes into 8 how many times? 4. So I multiply that old denominator of 1 times 4 to get the new denominator of 4. 8 goes into itself once, so I multiply the old denominator of 11 times 1, and we get 11. So usually when your old denominator is the same as the LCD, nothing changes. So now they both have a denominator of 8, so we just add 4 and 11 to make 15 eighths. And again, if you really want to, you can go ahead and change that to a mixed fraction or a mixed number, but as long as it's simplified, it's fine as an improper fraction. All right, in the next method, the KB method, we say, okay, let's multiply the denominators. So what do we get here? We get 16. And then what do? We say, okay, let's go across. Okay, 1 times 8 is 8. 2 times 11 is 22. So 22 plus 8 will get us 30 over 16, right? And now you just have to simplify. You have to think and say to yourself, think of a number that goes evenly into 30 and 16. Well, I would say 2. 2 goes into 30 15 times, and 2 goes into 16 8 times. And you see we have the same answer. All right, and maybe let's do one more for the road. All right, in this next one, the problem reads 3 tenths plus 2 fifths. Right, and I'll write it again on this side so we can do the other method, 3 tenths plus 2 fifths. All right, so next the LCD of 10 and 5 is 10, right? 10 is the smallest number that 5 and 10 can both go into evenly. 10 goes into itself once, so therefore I multiply 1 times the old numerator to get my new numerator. 1 times 3 is 3. 5 goes into 10 twice, so I take that and I say let's multiply that times the old numerator of 2. So I get my new numerator of 4. They both have the LCD of 10, so we just add 3 plus 4 and get 7. Now we're doing the other method where we just multiply the denominators. 10 times 5 is 50. 50 here. And then we say, what's 10 times 2 and what's 5 times 3? Well, 10 times 2 is 20. 5 times 3 is 15. Now they still have the same denominator of 50. 20 plus 15 is 35. And now you just have to reduce. So you just say to yourself, okay, what number out there goes evenly into 35 and 50? I would say 5, right? Because when you have 5 at the end of the number and the 0 at the end of the number, usually they're divisible by 5. So 5 goes into 35 7 times, 5 goes into 50 10 times. Same answer. And that was two different methods of adding or subtracting. We didn't do any subtraction problems, but if it were subtraction, you would just go ahead and subtract. So this was adding or subtracting fractions that are unlike, different denominators.